Remember graphing complex numbers. Say that's 3 plus 4i.
What?
Do you remember when you were graphing these? Or do you remember graphing them in Algebra 2? Yeah. So if you're graphing imaginary numbers, we label one of the axes real and the other one imaginary. So 3, 4, how much of this is real? And how much is imaginary? So we go to 3, 4. Right there. What? Okay. How about -2 plus I? Yeah. So graphing fairly easy, right? Now let's start with the definition. Now, oftentimes we're going to use z equals a plus bi as our standard for writing an imaginary number. So a is the real part, b is the imaginary part. Right? Now the question is, how do we get the absolute value of z? Okay? Think about what does the absolute value mean? So how would you describe it? Okay, so it's positive always. Okay, what else? But what would you describe it graphically? Or not the graph. I mean, say if we had our number line here. 0, 1. What is the definition of absolute value? No. What's the definition? The distance from 0. So if we talked about 3, how far is 3 from 0? So absolute value of 3 equals 3. If we were at -2, how far is -2 from 0? So when you talk about absolute value, it is the distance from 0. Okay? Does that make sense for absolute value? When you talk about absolute value of complex numbers, we go with the same rule. What is the distance from 0? However, instead of being a one-dimensional thing, we do 2 dimensions. So how far is this from 0 to 0? If you think, how long is this? Yeah, 5. Because you've got, this side would be 3, 4. 3 squared plus 4 squared is 25. This would be 5. So the absolute value of 3 plus 4i is 5. Does that make sense? So how would we do absolute value of this one? Yeah, root 5. Right? What it is -2 squared plus 1 squared. So what would the formula be if we have it in this form? Square root of a squared plus b squared. So everybody with me? Does that make sense how where we got that? Now, writing these in polar form. What do you think the radius is going to be? Okay, squared of a squared plus b squared. So follow the same rule with that. What would x be? cosine of theta, or r cosine theta. Remember, what our x coordinate is what in terms of, well, remember, what's the formula for x in polar form? R cosine theta, is that what's familiar? And y, r sine theta. Okay? So we can rewrite z into this form. R cosine of theta plus r, looks like I, r sine theta. Very good. The amount in the x direction plus the amount in the y direction. So we've got x plus I, y. Do you see the similarities in this form? So it's a plus bi. Remember, a was how much we went in the real direction. B is how much imaginary direction. Anybody stuck yet? Okay. Now, we're going to be multiplying some of these. So if we have z1 and z2, so we have z1 equals a, that's just 2, r, and you're going to factor out the r, so I'm going to get cosine of theta 1 plus I sine of theta 2, or theta 1, sorry. So this is one point, or one thing, one imaginary thing. And v2 will be r2 cosine of theta 2 plus I sine of theta 2. So now, instead of talking about just a single one, we're talking about two separate ones. If I want to multiply these together, so we have v1 times v2. What do you think we're going to get? Okay, r1, r2, multiply together. And notice, we're going to be multiplying this times this, right? Now, anybody remember the rules for that? I mean, back when we dealt with trigonometry, we'd be had rules about multiplying cosines together. So we can either go through the rules, or we can just go with straight to the formula. Okay, thankfully the formula is fairly simple. Let's put it bracket cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. But if you went through the formula, remember we had the rule about multiplying sine and cosine together, that would get you common difference inside. Remember the formula? Okay. Oh no, I think it was like end of chapter 4 or the end of chapter 5, I don't remember. But we could multiply these together, and we would come out with this answer. Some of them would be canceling, and so on. So what do you think v1 divided by v2 is going to be? Okay, r1 over r2. Okay, cosine of theta 1 minus theta 2. Yeah, plus I sine of theta 1 minus theta 2. Now, what restrictions might we need to put in here? R2 can't equal 0, and V2 can't equal 0. I'm not going to write them, however, you would want to make sure you keep in mind that if you had R2 equals 0 or V2 equals 0, we're going to be divided by 0 and have a problem. Next one. Z raised to the n. So we're going back to z equals a plus bi. So n is a natural number. So in other words, n equals 1, 2, 3, 4, 5, 6, 7, something like that. So we could say z to the 5th power, or z to the 225th power, or whatever we want. And the rule, Rn cosine of n theta plus I sine of n theta. Fairly simple, right? The last one is the one that's a bit more complex. This one's a bit more. We're going to go back and do some examples of these, but first we're going to look through them. Last one is the most complex of them. No, natural numbers are only positive. So we're only doing 1, 2, 3, 4 positive integers.
Does not include 0.
Does not include 0. And this is the last one. The peak root of z. Meaning we're looking like the 5th root, or the 8th root, or the 23rd root of z. Yes, just hope you never have to do the 23rd root. Is equal to r raised to the 1 over p times cosine of theta plus 2n pi over p plus I sine of theta plus 2n pi over p, where n is 0, 1, 2, count it up until you get p minus 1. Okay, so that's where we're at. Now, we're going to do some problems with you. Everybody ready? Yeah, everybody. Oh, okay, so no, there's an n in the formula right here and here. We're going to have several different roots, meaning we don't just have one root. We're going to find 5 roots or 6 roots, depending on what p is. So if p is 8, we're going to have 8 roots that we need to find. If p is 4, we're going to have 4 roots to find. So we're going to plug in 0, get, and then all the way up until. Correct. Okay, so let's see. First, let's say z equals, let's go 8 plus 4i. Change its trig form. What should we do? Okay, so we can get r equals what? Four root 10? I think 5? Okay. So how do we get, so first we have to get r, which is a squared plus square root of a squared plus b squared, so 64 plus 16 gives us 80. Square root of 80 equals square root of 16 times square root of 5. Now we have to get theta. How do we get that? Okay. So we can think of it as a triangle where we've got 8 in the real direction, 4 in the imaginary direction. And we've got 1 over 2. What angle will have tangent equal 1/2? So we can do the tangent of theta equals 4 over 8. So theta will be approximately what? Give me in radians. What do we get as radians? 0.46. So our form, if we want the trig form, z will equal r, which we calculate up here, 4 square root 5 times cosine of our angle, cosine 0.46, plus I sine of 0.46. And we have trig form. Well, if I was just asking write it in trig form, yeah, that's all you're doing. Now, if this was a nice number, so maybe it was root 2 over 2, we could say what angle it is. But with this, we don't know what angle. Or we don't have a nice angle, I should say. So now let's go do another one. Another type of problem. Let's say 4 plus 4 square root 3i raised to the 6th. So which one of the rules are we using? Yeah. So first we have to put it in z form, or trig form. What's r going to be? That square. So first, r equals square root of 4 squared plus 4 square root 3 squared, which is 64, which gives us 8. So r equals 8. Then what's our angle? We have 4 square root 3, 4 divided by 4 root 3 divided by 4 is root 3. So what angle is tangent for the root 3? Or what is this going to be? Because this is one of the ones we know. One of the ones in the unit circle. Very easy one. If we know this would have to be 8, right? 4 over 8, where is cosine equal to 1/2? Okay, pi third. Anybody stuck on that? Okay, so theta will equal pi third. Okay, so z is going to be 8 times cosine of pi third plus I sine pi third. Now let's use the formula, where n is 6. So z to the 6, I think that's what we started with, yes, is equal to 8 to the 6 times cosine of 6 times pi third plus I sine of 6 pi third. Okay? Anybody stuck on everybody follow where we got that? See it, Sydney? And Ivy? Yeah, that's our formula back here. Right here is the one we're doing. We're putting in whatever number we had here, right there. Okay. So what's 6 times pi divided by 3? Okay. Well, we have cosine of 2 pi. What is cosine of 2 pi? 1. So 1 plus, what's the sine of 2 pi? So I sine 0 What's I times 0? 0. So that's going to go away. Times 1. So what is 8 to the 6? Eight. 262, 144. So this raised to the 6th power is 262, 144. So all we do is step by step, plugging stuff in. If you end up with a not nice answer here, you would just have to plug it into the calculator and say the sine of like 6 pi 7 or whatever it happened to be. Now we're going to do another problem. This one we're going to do the root, because those ones are the more complex ones. So find fourth root of -4 minus 4i. So -4 minus 4i, so we're down here. So this is -4, -4. What's the angle going to be? Yeah. So what's the angle from here all the way around? 5 pi over 4. Okay. And what's the radius going to be with these? Are they on 45, 45, 90? 4 square root 2. So now, we want to do the fourth root of, we have r, the 4 root 2 of, with cosine 5 pi 4. Just a second. Because we want, if we just did pi 4, we'd be talking about this angle right here.
Oh.
Or if we just did, 45 degrees, we'd be there. But we wanted this angle down here. Over here?
Yeah.
7 pi 4. So now our formula. So it says we do our answers. R raised to the, so we got 4 square root 2 raised to the 1/4 times the cosine of 5 pi over 4. So what does n start at? 0. Remember we had n equals 0, 1. Where are we going to stop for this one?
3.
Yeah, so 0, 1, 2, 3. So because it's 4 roots, we're going to have 4 answers. So we're going to go plus 0 times 2 pi over 4 plus I sine of 5 pi over 4 plus 0 times 2 pi over 4. Thank you for that paper. Yeah, then we're going to do the next one. So I'm going to leave a little space here. 4 root 2 raised to the 1/4 cosine of 5 pi over 4 plus 1 times 2 pi over 4 plus I sine of 5 pi over 4 plus 1 times 2 pi all over 4. Okay, and then we do it 2 more times. So 4 square root 2 raised to the 1/4 cosine of 5 pi over 4 plus 2 times 2 pi over 4 plus I sine of pi over 4 plus 2 times 2 pi over 4. And last one. as you can see, doing the roots takes a bit of time. Now, I suspect none of these are going to give us nice answers, which means we would just plug this into the calculator. So 5 pi fourths plus 0, so this is going to be 5 pi over 16, and 5 pi over 16. Yeah, not going to be a nice answer, so we can plug in all of this, our cosine of this, you get our real part, times that part. So somebody's calculator, do 4 root 2 raised to the 1/4, and then cosine of 5 pi 16. And somebody else? So who's doing that one? Okay. And somebody else? Doing the same thing over here, except we're just doing 4 root 2 raised to 1/4 times the sine of 5 pi over, or 5 pi 16. Yeah, right? 5 pi 16, because all of this added together is just 5 pi 16. Okay, so we get 0.86 plus pi times yes? Okay. What? It doesn't sound right. So you did this 4 root 2 raised to 1/4 times sine of 5 pi 16. Yeah, that sounds right neighborhood. Are you getting that? Are you doing it, Sydney? Are you in degree or radian mode? Right. So I believe it should be 1.28 I. Now this is our decimal approximation, our rounded answer. If we wanted the exact answer, how are we going to get the exact answer? So first, how do you simplify this? What? Oh, 4 square root 2 raised to the 1/4. Okay, so I'm going to rewrite this as maybe 16 square root of 16 times square root of 2 raised to 1/4. Right? But 16 times 2 is the square root of 32 to 1/4, and this can be written as 32 to 1/2 raised to 1/4. So 32 to 1/8, or the 8th root of 32. Then I'm going to write the second one here in exact form. So depending on what it asks for, we've got the 8th root of 32 times, what's 5 pi 4 plus 2 pi? What? Okay. Sure?
Oh, 4x. Sorry.
So this is 8 pi over 4, 13 pi 4th, and then divide by 4, by 16, plus I sine of 13 pi over 16. So there's the decimal form, there's the exact form. And note, we could change it back and forth without issues. Actually, change it to this form easy, change it back to this form, would be a bit more challenging. But there's the two different ways you might see it.